significant barrier in rice cultivation. Barriers in rice cultivation are climate change, temperature and precipitation pattern changing. Number two, declining in groundwater levels, declining soil organic matter content and nutrient availability, and increased soil salinization, and increased incidence of pest and disease. Solution of problems. To cater to the current challenges faced by rice cultivation, there is a need for sustainable technology to overcome the abiotic stresses, and the alternative management practices help to improve soil health and productivity and sustainability of rice feed system. Such technology include to sustain the productivity of rice, the direct seeding, furrow irrigated raised bed planting, timely transplanting, short duration varieties, basmati growing, leaf color chart, tensiometer, laser leveling. Besides the above technology, the adoption of recommendation of rice cultivation is also important. Agronomic practices for rice cultivation, climatic requirements best suited to region of high temperature, high humidity, prolonged sunshine, and assured water supply. Soil type, rice can grow well on soils with low permeability and over a wide range of soil reaction. For example, pH 5 to 9, generally clay loam soils are the best for rice cultivation. Improved varieties, sources of seed, and technology related attributes, perceived yield, maturity, ease of use, marketability, and technical efficiency are more important determinants of adoption, with the determinants changing according to adoption type, means probability or intensity of adoption, variety type, and regions. So use the recommended high yielding variety according to area or region. Application of farmyard manure, press, mud, and green manure means agronomic practices for rice cultivation. Number one, application of farmyard manure, press mud, and green manure. Apply 6 ton farmyard manure per acre and save 16 kg of nitrogen. If farmyard manure is not available, then green manuring of tencha, coffee, sun hemp is a practicable alternative. After harvesting of wheat, apply Roni irrigation, means before sowing irrigation, 20 kg seed per pre-soaked 20 kg seed pre-soaked in water for 8 hours, or 12 to 20 kg per acre of coffee, or 20 kg of sun hemp, sow up to the first week of May. Use 75 kg super phosphate in soil low in phosphorus. Omit phosphorus to rice crop. Bury 6 to 8 weeks old crop in the soil. Tencha is preferred in color or a recently reclaimed soil. This practice results in saving of 25 kg nitrogen, means 55 kg of urea per acre. To get higher yield, apply recommended dose of 50 kg nitrogen per acre to rice grown loamy sand to sandy loam soils. Green manure with the tencha also ameliorates iron deficiency in rice. Press mud, apply 6 ton press mud per acre, save 1/3 dose of nitrogen, and omit phosphorus application in low soils of phosphorus. Land preparation, seed rate, and seed treatment. Land preparation, prepare all bunds, obtain a fine, well-leveled puddle to reduce water loss through percolation, to maintain good seedling vigor and control weeds. Use laser land leveler for precision land leveling before puddling to enhance water use efficiency and other farm inputs. Seed rate, separate the immature seed by dip in the suitable lots of water contained in the tub or bucket. Stir the seed and remove immature seeds which float at the top. Thus, heavy seeds will settle down at the bottom. 8 kg of heavy seed is sufficient and ensure healthy, sturdy, and uniform seedling. Seed treatment. Soak the selected seed in 10 liters of water containing 5 gram amisan, 6 and 1 gram streptocycline for 8 to 10 hours before sowing. Time of nursery raising 15 to 30th May. Transplantation dates of transplanting second fortnight of June. Uh, for the varieties PR120, PR118, PR116, PR114, PR113, and PR111. June 25 to July 5, PAU 201. Under late sown condition, PR115. Age of seedling 25 to 30 days old. Seedling under late transplanting for long duration varieties 30 to 55 days. For short duration varieties 25 to 30 days. Uprooting of seedling, irrigate the seedling before uprooting and wash the seedling to remove the mud. Method of transplanting, flat puddle transplanting in lines at 20 to 15 centimeter, 33 hills per square meter for normal. In lines at 15 into 15 centimeter, 44 hills per square meter for late. Put 2 seedlings per hill, 2 to 3 centimeter deep. Advantages: ensure good establishment of seedlings, early tillering, which are essential for good tiller development, and synchronous flowering. Bed transplanting. After field preparation without puddling, apply basic dose of fertilizer and prepare beds. Prepare the beds with wheat bed planter on heavy textured soil and transplant 30 days old seedling on the middle of the slope. Transplant the seedling at a distance of 9 centimeter plant to ensure 33 seedlings per square meter. During first 15 days after transplanting, irrigation water should be allowed to pass over the beds once in 24 hours. Therefore, apply irrigation in furrows only 2 days after the mounded water has infiltrated into the soils. Care should be taken that feed does not develop cracks in the furrows. Bed transplanting. Weed control in bed transplanting. Spray Nomini Gold 10 SC by Bispirabic bag Disparibac at 120 ml per acre in 150 liters of water as post-emergence 20-25 days after transplanting. Hand pulling of weeds can be done if needed. Follow other cultural practices as recommended for flat puddle transplanted rice. Advantage: in this way, about 25% of total applied irrigation water can be saved without affecting yield. Weed control. Interculture both early or timely transplanted crops with a paddy weeder at 15 days after transplanted and again after a fortnight. Where a paddy weeder cannot be run, hand weeding may be done. Use of herbicides. Efficient and economical. The following herbicides are recommended for use in transplant rice 2 to 3 days after transplanting. Name of herbicide: dose and 150 liters water per 60 kg sand. Butachlor 50 EC 1200 ml 60 kg sand. Machete and Delclor or Punch, Thunder, Capolor, all these 1200 ml and or 60 kg sand. Butachlor 50 EW fast mix 1200 ml 60 kg sand. Thiobancar 50 EC 1200 ml 60 kg sand. Saturn Anilofos 18 EC, Erogen 800 ml 60 kg sand, Anilofos 30 EC 500 ml 60 kg sand, and Erogen, Libera and control, etc. Use of herbicide continue. Anilofos 50 EC, Anilogard 300 ml 60 kg sand, Pendimethalin 30 EC 1200 ml 60 kg sand, Storm. Low dose in light soils and higher dose on medium to heavy soil. Paraticlor 50 EC 600 ml 60 kg sand, Rift, Raise, and Paragelfuran ethyl 10 WP 60 gram 150 liter of water. Sathi Diarrhyl 80 WP 45 gram 150 liter water, top star. The liquid formulation of these herbicides are applied in 4 to 5 centimeter deep water and are effective against smack, Cunocloa cruscally, and give moderate control of two other weeds. Erogen, Anilogard, Libra, Control H35, 30, Control H30, Pesto Anilifos, Marcanil, and Jeffos, Haragro, Anilifos have an edge over other herbicide for control of Istium rugosa wrinkle grass. And alternatively, post-emergence spray of nominee gold 10 SC at 100 ml per acre in 150 liters of water at 20 to 25 days after transplanting. Before spray, the standing water from the field should be drained out and irrigation may be applied one day after spray. Note, do not use one group of herbicide for year after year, result in the appearance of new weed types. Caution, use hand gloves while applying these herbicides. Control of broadleaf weeds. For control of broadleaf weeds, including Gorilla, Sisulia, Axillaria, Sunny, etc. Apply L-grip, metsulfuron 20 WP at the rate of 30 gram per acre in 150 liters of water as post-emergence. 20 to 25 days after transplanting, or sunrise 15 WDG ethoxy sulfuron at 50 gram per acre, or Londex 60 DF at 40 gram per acre, or segment 50 DF at 16 gram per acre 15 to 20 days after transplanting. Before spray, the standing water from the field should be drained out and irrigation may be applied one day after spray. The spray should be done on clear and calm day in order to attain the good efficiency of the applied herbicide. Delay in application results in poor control of these weeds. Irrigation and drainage. Proper water management holds the key to successful rice cultivation. Keep the water standing continuously in the crop for 2 weeks after transplanting for proper seedling establishment. Afterwards, apply irrigation 2 days after the ponded water has infiltrated into the soil. To save irrigation water, irrigate with tensiometer installed at 15 to 20 centimeters soil depth at soil metric tension 150 plus minus 20 centimeter, or when water level in tensiometer enters yellow strip. Yellow strip. Care should be taken field does not develop cracks. In this way, irrigation water can be saved without causing any reduction in yield. The depth of standing water should not exceed 10 centimeter. Drain away excess water before interculturing or beating and irrigate the field after these operators. Stop irrigation about a fortnight before maturity to facilitate easy harvesting and the timely sowing of succeeding rabi crops. Note, ensure timely application of weedicide for all benefits of standing water. Fertilizer application. Nutrients kg per acre. Nitrogen 50 kg. Available phosphorus 12 kg and potassium 12 kg. Urea 110, DAP 27, superphosphate 75 kg, muriate of 20. Apply on soil test basis. Make appropriate reduction for green manuring and farmyard manure and pest mud. When DAP is used, reduce the urea dose by 10 kg. Time of fertilizer application: apply 1/3 nitrogen, whole phosphorus and potassium before the last puddling. Broadcast the remaining nitrogen in 2 splits, one 3 weeks after transplanting, the other 3 weeks afterwards. If possible, apply the second or third dose of nitrogen when water is not standing in the field. Phosphorus can be top dressed up to 21 days after transplanting. Irrigate on the third day of the application of fertilizer. Skip phosphorus application to rice if a recommended dose has been applied to the preceding wheat crop. Reduce nitrogen dose by one third for burying summer moong after picking pods 1 day before transplanting. Use of leaf color chart. Chart. It is used for need-based nitrogen fertilizer application to rice. Apply a basal dose of 25 kg urea per acre at the last purling. Match the color of youngest fully expanded leaf. Second from the top of 10 randomly selected disease-free rice plants per hill from each field with the color strip of the LCC 7 to 10 days, starting from 2 weeks after transplanting of rice till initiation of flowering. Every time the greenness of 6 or more out of 10 leaves is less than the shade 4 or the LCC top dress 25 kg urea per acre. If the color of 6 or more out of 10 leaves is greener than the shade 4 on the LCC, do not apply urea. Always compare color of the leaf with LCC under shade of your body and around some time of the day, preferably by same person around 9 to 10 am or 4 to 5 pm. Need-based nitrogen management using LCC holds good for all the prevalent rice varieties grown in all types of soil. Use LCC for applying nitrogen to rice also when fields are recommended with organic manures. Availability of LCC. LCC is manufactured by Peritech Plast Private Limited, 25 Yarangana Jargana JP Nagar Post, Bangalore 560078, or Head Department of Soil, Punjab Agriculture University, Ludhiana. Caution: excessive use of nitrogen fertilizer, particularly during flowering, causes sterility and consequently heavy reduction in yield. Zinc deficiency. The symptoms of zinc deficiency appear 2 to 3 weeks after transplanting. Symptoms: the lower leaves become rusty brown near the base and ultimately dry up. The seedlings remain stunted and tillerless. Control: apply 25 kg of zinc sulfate heptahydrate or 16 kg zinc sulfate monohydrate per acre at puddling in case of previous crop had shown the symptom. Where the deficiency is noticed in the growing crop, apply this quantity of zinc sulfate as soon as possible. In a highly deteriorated soil, the symptoms of zinc sometimes appear in patches even after application of recommended dose of zinc sulfate. Then broadcast 10 kg of zinc sulfate heptahydrate or 6.5 kg zinc sulfate monohydrate per acre mixed with an equal quantity of dry soil on the affected patches. Iron deficiency. Under scarcity of water, chlorosis among seedlings appears in the youngest leaves about 3 weeks after transplanting. Plants die and often the crop falls completely. Start giving copious irrigation as soon as chlorosis appears and give 2 to 3 sprays of 1% ferrous sulfate solution at weekly interval. 1 kg of ferrous sulfate in 100 liters of water per acre. Cultivation in alkali soil. Addition of gypsum. Add as per the soil test report and give 1 or 2 heavy irrigation. Preparation of seed bed. Do not puddle because water intake rate in these soils is very low. Irrigate the tilled field and give light planking to pulverize the clods of, if any. Transplanting. Transplant seedling a week earlier than normal because the initial growth of plants in alkali soil is slow. Plant 3 or 4 40 days old seedling per hill. More seedlings per hill are recommended because of higher mortality in these soils. Fertilizer application. Apply 20 to 25% of more nitrogen than in normal soil. Alkali soils are low in organic carbon and the efficiency of nitrogen fertilizer is slow. Apply 60 kg nitrogen through 130 kg urea per acre in 3 splits. 1/3 at transplanting, 1/3 at 3 weeks after transplanting, and remaining 1/3 after 6 weeks After transplanting, apply the same amount of phosphorus as the normal soil. In addition, apply 25 kg of zinc sulfate heptahydrate or 16 kg zinc sulfate monohydrate per acre during the preparatory tillage. When tencha is ground for green manuring, add the quantity of phosphorus recommended for rice to this legume and omit the application of phosphorus to the succeeding rice crop. Harvesting and threshing. Harvest the crop just when the ears are nearly ripe and straw has turned yellow. If harvesting is delayed till the crop dead ripe, the shattering of grains occurs. Thresh the harvested crop on the same day and do not leave it in the field exposed to dew. If it has to be left there overnight, cover the heap with a polythene sheet. The grains remain exposed to dew at night, develop sun cracks during the day and break on milling. Production of pure seed. Select a good plot of the seedling crop, rogue it thoroughly so that it is made free from all admixtures and diseased plants. Harvest and thresh this plot separately. Dry the produce well and store separately in disinfested bins. Conclusion. Eco friendly practices are crucial for shaping the future of rice farming. Although rice cultivation provides millions of people with food and a means of subsistence globally, it also has a substantial negative impact on the environment due to greenhouse gas emission, water usage, and soil degradation. Please subscribe, like, and comment. Thank you.